Hello, my name is Dimitar Kristev, I work for KS Group, and today we're going to take a quick look at our latest product called Phoenix Fluid Dynamics. Phoenix Fluid Dynamics is a grid-based simulator that you are going to use to create and to render different kinds of smoke and flame-based effects inside of 3D Studio Max. In this short demo, I'm going to go over some of the basic features of Phoenix and show you how to quickly set up a test simulation that you can use to explore and experiment with the different settings of the product. The first thing we need to do is set up our system units correctly. In my case, I'm working with meters and I have set one unit to be 1 centimeter. This way, I will know exactly the size of my simulation and I can anticipate the final result more accurately. Next, I will create a Phoenix simulator. This can be found in the Create tab under the Geometry section. It allows me to control the simulation settings and determines the boundaries for the simulation. To adjust its size, I'm going to go to the Modify tab and in the Grid Rollout set one cell to be 10 centimeters in each direction. Then, I will set up the grid to be 2 by 2 by 4 meters. Finally, I will increase the resolution of the grid so that I have a more detailed simulation. And since we are going to go and run a temperature-based simulation, I will make the grid adaptive to temperature. Now that I have the simulator, I need to add an object to emit the fluid. In my case, a simple sphere will suffice. Then I will go to the Helper section and create a Phoenix source. The Phoenix source allows me to set the initial conditions of the fluid and to specify which objects are going to be emitting the fluid. In my case, this is the sphere, so I'll add it in the list. In here, I can also add particle systems as well as other Phoenix simulations in order to create some more complex simulations. Finally, I will set my animation length to something big so I can try the different settings without having to constantly restart the simulation. Then I will select my Phoenix simulator and click Start. We can immediately see some flames rising. I can now select the source and adjust the initial conditions of the fluid. I can control the amount of the fluid with the discharge parameter. Adding more fluid to the simulation makes it more violent, so I'm just going to leave it there. Then I can adjust the temperature of the fluid and make it hotter or colder. You can see that as I meddle with these settings, here the simulation is immediately affected. I can also add new objects in the scene and the simulation will react to them accordingly. I will create a box and put it in the path of the flame. As you can see, Phoenix automatically reacts to the new geometry. I can also add forces. For example, a wind to blow the fire in a certain direction. Now, let's remove those and check out some of the settings of the simulator. I'm going to select it and start playing with the different options. Up here we have an option called Wind from Movement. This means that if I move the burning object in any given direction, Phoenix will automatically generate wind to blow the flame in the opposite direction. This is done automatically for you and you don't have to create the wind manually. The next option is called Timescale. It basically allows me to speed up or slow down the simulation. The next parameter is called Vorticity and it allows me to make the flame more or less turbulent. When I decrease it, the flame becomes more laminar and if I increase it, the flame becomes more turbulent. The pressure decay parameter allows me to simulate the effect of atmospheric pressure dropping down as you get higher in the atmosphere. It is basically a multiplier, and it is useful if I want to simulate a very large explosion, like a nuclear explosion for example, which leaves a mushroom-shaped cloud. Now I can directly hit render while the simulation is still running. To adjust the way the flame looks, I'll go to the rendering rollout and click on the colors and transparency button. In the emission rollout, I have a preset that creates a rendering of a fire with physically accurate colors and intensity. I can play with those settings and try to create a differently looking result. Up here, we can specify the colors and in the graph we have the intensity of the light matched against the temperature of the fluid. Now let's quickly try and set up a blue flame. I'll adjust the colors and hit render to see the result. Up until now, we were running a simulation that was entirely based on the temperature of the fluid. I just want to show you how you can run a smoke-based simulation, and I'll leave you to experiment on your own. The first thing we need to do is disable the temperature channel and enable the smoke channel in the output rollout of the simulator. Then I'll set the initial temperature to 300 degrees Kelvin, which is the temperature of the simulator. This way, the temperature will not affect the simulation in any way. Finally, I'll just add some smoke. Now when I start the simulation, we'll see some smoke building up. I will make the grid adaptive to the smoke, and I will also increase the smoke buoyancy to make the smoke flow upwards. To adjust the render, I will again click on the colors and transparency, and this time I'm going to use the smoke channel for diffuse color and again the smoke for transparency. Hit render and we see a normal gray smoke. To add some color, I will play with the settings in the diffuse rollout. These are some of the basic settings of Phoenix. We have a lot more going on, but for now I would suggest that you go to our website, download the free demo version and try it for yourself. We're going to explore some of the more advanced uses of Phoenix in another video. Thanks for watching and goodbye.